All right, welcome to topic 1.5. In this video, we're going to be working through metric conversions. So building off of what we began in the previous topic in our introduction to conversions. Okay, so the first thing that we need to do before we start on the actual problems is we need to work on the Holy Grail sheet and make some things adjusted to it. So what we're going to do first is here in this middle section, we're going to add the word base unit or words. And there are 4 base units that we primarily work with in chemistry or in science, and that is the meter, the gram, the liter, and the second. Okay. Base unit is a power of 1 because metrics is based on powers of 10. And so we have different prefixes that we use to work with metrics that represent a different power of 10. So when we take a look, we have things like tera, giga, mega, kilo, hecto, deca. Notice that tera, giga, and mega are these capitalized T, G, and M. We have lowercase k for kilo, hecto is H, and deca is kind of interesting that it's DA. We have deci, centi, milli. We have this funky letter for micro. We'll talk about that here momentarily. Nano and pico. A lot of times students end up misusing these times 10 with the exponent. So I'm going to have you scribble those out just so it's something that you don't get goofed up with as we work on metrics. The other thing I'm going to have you do is on the left-hand side, we're going to underline these letter M's. And we're going to do the same thing with the right-hand side. Underline all of these letter M's. Because depending what you're measuring, like M for meter is a distance measurement, we use grams for mass, we use liters for volume, and we use seconds for time. So the idea here is anything that has an M for meter can be substituted with the G, L, and S that come in those parentheses. Same thing with what's on the right-hand side of the equal sign. We can substitute in a G, L, or S for any of these M for meters, and we'll see that here in a moment. So we're going to go ahead and get started working on our problems. How I have the notes set up is I have 2 sections, 1-step problems, 2-step problems. Okay. In these 1-step problems, we are doing one of 2 things. We're going from a base unit, and again, just to remind you, the base unit is M, G, L, and S, meters, grams, liters, seconds. And then we're going to a prefix being any of these 10 options. Over here, we have a prefix to a base. So we'll start with one of these and make our way to the base. Okay, so let's talk about what all of that information means. So to start here, we're given 563 meters. If you understand the word prefix, we know a prefix goes at the start of a word. So notice there is nothing before the word meter, meaning there's none of these attached prefixes. So this is a base unit. It's one of the 4 where nothing again is associated there. It's asking us to change it to millimeters. So this problem is a base to prefix. We're starting with nothing tacked on to the word meter, and we're changing it to a smaller prefix, milli. Okay. So we then work on setting up our conversions. That setup and how we align our units is all the same from our previous lesson. We need to get our conversion factor. So if you're not sure, we know that milli is found over here, and this is the abbreviation for milli, lowercase m. We get our conversion factor here, that 1,000 millimeters is to 1 meter. Okay. Looking at what I have for units, 1 meter is going to go in my denominator, and 1,000 meters is going to go in the numerator. Looking at how units line up, my meters are canceling, and what I'm doing here is multiplying. So if you're not sure, we're essentially moving the decimal, we're adding zeros to our number, and since we're multiplying by 1,000, and let me get this out of scientific notation mode, we're just adding 3 zeros onto our number. So our answer becomes 563,000, and our unit is now in the millimeter. So we started at a base, and we went to the prefix. Okay. When we look at the next example, we start out with 7.8 and we have micrograms. So I can see that one of my 4 base units, the gram, has a prefix attached to it. I'm looking for micro, which is here. This is the Greek letter mu. Because we use capital M and lowercase m, we're stuck here with micro, which is the Greek letter mu. How I make that symbol is I make a line, and then I draw a U off of it. And that's how I make the Greek letter mu. Okay. So because we're starting at micrograms, we're starting at a prefix. It's asking me to change this to grams, which is a base unit. There's nothing associated with the front of that unit. So this also means it's a one-step problem. I need to then use my Holy Grail sheet to figure out what is the relationship between the microgram to gram. I find my prefix micro. I can use this right-hand side to find that. I follow it over. And this is what I was talking about, these M's. So right now it says 1 million micrometers. We're not measuring meters, we're measuring grams. So M can become substituted with G, L, or S. So 1 million micrograms is to 1 gram. Again, the M's can be replaced with G, L, and S. So 1 times 10 to the 6th micrograms is going to go in the denominator, and 1 gram is going to go in my numerator. When I look at unit alignment, micrograms is going to cancel, and I'm going to go ahead and divide. Okay, so I'm going to take 7.8, and I'm going to divide that by 1 times 10 to the 6th. Or you can write it out as 1 million. I got a little ahead of myself. You can use either variation. You can use standard, or you can use scientific notation. So my camera isn't liking this screen too much. Let me see if I change my brightness. There we go. That's going to help. Now it's all right with it. So I'm going to go ahead and divide that, and I get 7.8 times 10 to the negative 6th. And that is grams. You could also write out 0.0000078 grams. So either way is fine. You can use standard notation or scientific. Same thing with up here. You could put 5.63 times 10 to the 5th power. So the theme is, if you start or end at a base unit, the 4 options are meter, gram, liter, and second. It's a one-step problem. So what do you do when you're not going to a base unit or starting with a base unit, meaning we have 2 prefixes? This changes our setup a little bit. Here, we're starting with 67 kilograms. We're starting with a prefix here. We're changing it to centigrams. So I'm going from one prefix to another prefix. So this changes a little bit on what or the number of steps needed to solve. So when you do a prefix to prefix problem, your steps take a prefix, you change it to the base, and then we change it to our desired prefix. Well, let's talk about what that means. We're starting with the prefix kilograms. We need to change kilograms to centigrams. So the middleman here, the base unit, if you're not sure, you cover up the prefix, and what's left is G. The base unit is the gram. This gives me the 2 steps I need to solve. This is step 1. This is step 2. Okay? I start with writing out my given of 67 kg. I look at how do I line up units to cancel. I'm looking to take kilograms and change it to the base unit. If I'm not sure where I'm at on my conversion factor, I can find kilo over here on the right. You follow this over, and this is one that students often mix up. They realize that kilo means 1,000, but they often say 1,000 kilo. No, kilo is 1. It is made up of 1,000. So I'm starting with kilograms. So again, I can substitute M with G, so 1 kilogram, and that's the bottom because I need to divide to make those units cancel. That's equal to 1,000 grams, and that 1,000 grams is the numerator. Kilograms is going to cancel there, and I've done the first step in this process. I need to then change grams to centigrams. Okay? So here, we're going to go ahead and take a look, and we have centi. 100 centigrams equals 1 gram. 1 gram goes in my denominator. 100 centigrams becomes my numerator. Grams cancels. Mathematically, what we're doing is multiplying. Everything is in the numerator. So we're going to take 67 times 1,000 times 100. So we end up with 67, and it's followed by 5 zeros. You could also report it to 6.7 times 10, and I'm going to go ahead and just swap that over to the 6th. Either one is an acceptable way to report your answers, and that's centigrams. Okay, so from there, we're going to work on another prefix to prefix. In this problem, we're starting with 0.58 megaliters. So this is a prefix, mega. If you look at your Holy Grail sheet, mega is set up with a capital M. Okay, so capital M here for mega. And then we're changing megaliters out to centiliters. Okay, here's centi, lowercase c. So it's a prefix to prefix, and we're changing it from mega to centi. Like the previous one, we need to go through the base. The base unit, you cover up the M and the C, and you're left with liters. Liters is the base unit. I'm going to go ahead and write out my given of 0.58 megaliters. Because I know I'm starting with megaliters, megaliters will be in the bottom, liters will be the numerator. Let's get the values. Megaliter, it takes 1 million liters to make 1 megaliter. 1 megaliter is going to be the bottom. 1 million is the numerator. You could also write it as 1 times 10 to the 6th. Again, you can pick your method that you like, standard or scientific. Milliliters cancels. And we need to work on then changing liters to centiliters. Getting my prefix centi, it tells me 100 centiliters equals 1 liter. Because I have liters here, 1 liter will go in the denominator. 100 centiliters is my numerator. Similar to the previous problem, everything's in the numerator that I care about, so I do not need to use division here. So we take 0.58 times 1 times 10 to the 6th, or 1 million, times 100. I get an answer of 5.8 times 10 to the 7th centiliters, or it's 5.8 followed by 6 zeros. Again, either method is acceptable. So the last 2 problems in the mixed review, we're going to set these up, but what you need to decide is this a 1 or a 2-step problem? In this problem, I'm given 547 kiloliters. Kiloliters is a prefix. I'm changing it to milliliters, which is also a prefix. A prefix to prefix problem is always 2 steps. And the 2 steps will involve you changing the prefix to the base to the new prefix, just like the 2 problems above. We're going to take kiloliters, change kiloliters to liters, and then solve for milliliters. Okay. How this plugs in. I need to find my info, my conversion factor on kilo. So when I follow this through, 1 kiloliter is 1,000 liters. 1 kiloliter goes in the denominator, 1,000 liters in the numerator, and kiloliters is canceling. Milliliters. Here's milli, and 1,000 milliliters is to 1 liter. 1 liter in the denominator, 1,000 milliliters in the numerator. I did a poor job selecting problems here where everything just happened to end up in the numerator. Okay, I'm getting a little bit off my screen here. So what I do is I go ahead and multiply 547 times 1,000 times 1,000. So I'm essentially just adding 6 zeros to my answer. And in doing so, I get an answer of 547, or 5.47, excuse me, so 5.47 to the 8th power, or 547 followed by 6 zeros. And then our unit is milliliters. All right, last problem. We're starting out with 850, or 8,570 centiseconds. We're changing it to seconds. Centiseconds tells me I have a prefix. Seconds tells me I have a base. A prefix being changed to a base is a one-step problem. So if you start at a base, if you end at a base, it is a one-step problem. So go ahead and write out my given, and I abbreviate centiseconds as CS. I go to get my information. CS is going to be my denominator to divide, and that means seconds is my numerator. Seconds to centiseconds, there's 100 centiseconds to make 1 second. 100 is my denominator, 1 is my numerator. I go ahead and divide, and when I do that, I end up with 85.7 seconds. Okay? So again, this is how we work through metric conversions. You first have to decide 1 step or 2. Then you're using the top part of your Holy Grail sheet to line you up through those units. Please let me know if you have questions.